We'll proceed in sum series through integral calculus. Can we do summation of a series through integral calculus? This is a very broad topic. We are trying to do simple things, but this is a very broad topic, very broad topic in a way that anything is solvable through integral calculus. And the heart of this method is can we convert a can we convert a kind of discrete function into continuous function. If it is possible to convert discrete function into continuous function, then it would be possible to calculate the summation of series through integral calculus. Discrete function is nothing but the summation of series only. Discrete function is a function which is available at certain point on x-axis. If I have x-axis and I have a function and that is a function over x-axis called fx or y-axis. If this is x-axis, this is origin, then this is y-axis. This axis is also called function over x-axis. This is x-axis. At different x point, I have fx. Fx is the height. At different x, I have fx. Makes sense? If I have fx, if I have x-axis, this is origin. X equal to 0, x equal to 1, x equal to 2, x equal to 3, and so on. At x equal to 1, at x equal to 0, what is function over x? That will be drawn as vertical. I have so many vertical at different x equal to 1, 2, 3, 4, something like that. What is addition of all the vertical? This is what the summation of series is. Okay, how you prove it? Anyway, we are discussing about summation of x square. I mean 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square up to plus n square. Okay, 1 square plus 2 square plus 3 square plus 4 square plus n square. How we can tackle it? We divide this problem into n different parts, and each part is different. First part is 1 square, second part is 2 square, third part is 3 square. The concept is, can we make all the part behave exactly same? Can I make all the part behave exactly same? Yeah, it is possible. If I say each part is x square, x square, x square, x square, where x is variable in a way that we are trying to add x square plus x square plus x square plus x square n times. N times. Okay, we have many times we have given example. If I'm adding 2 plus 2 plus 2, then I can rewrite as 2 into 3, 2 into x where x is 3, and then 2 into dx, and then integration from 0 to 3. 2 I can write as function over x, means function over x into x will be converted into function over x dx, limit 0 to x. Similarly, I have now summation of x square plus x square plus x square plus x square, like so. And then we can write as x square into x, where x is n times, or x square is function over x into x, function over x into x, that will be converted into function over x dx, and limit will be 0 to n. Function over x dx, limit will be 0 to n. What is function over x? That is x square. X square integration will be x to the power 3 by 3. Okay, limit 0 to n to the power 3 by 3 plus some constant. This may not be a perfect solution, but this gives a hint at least that summation of 1 square plus 2 square plus 3 square up to n square is actually n to the power 3 by 3. It will be order of 3 of n. Okay, what is this is called successive addition. I'm sorry, repeated addition. If I am repeating addition, x square plus x square, I am repeating addition of x square up to n time. Or I would rather say we are trying to do sigma. Sigma is for summation sign. Okay, sigma x equal to 1 to n. sigma x equal to 1 to n fx function over x, where it is x square. Means I am summing x square plus x square, where first x square is 1 square, next x square is 2 square, 3 square, like so. Sigma sine x equal to 1 to n function over x, that is x square. Can we compute? So we tried repeated addition. Since it is x square plus x square plus x square x square, we can rewrite as x square into x square into dx, 0 to n. There is something called successive approximation, and that is the main concept that we will try to solve it. Successive approximation. And in successive approximation, we try to convert the discrete function into continuous function. What is discrete function? X square, function over x square. We talked about there is a function fx equal to x square, and x square has a value at x equal to 1, 2, 3, 4, 5, 6. It is not a continuous function. I cannot say let's take fx equal to x square, x equal to 3.5, then it is not available at all. 3.5 fx is not available. Fx is available only at x equal to 1, 2, 3, 4, 5, 6, 7, 8. So this is typically called discrete function. Discrete function means a discrete value of x, fx is available. So summation sigma sine x equal to 1 to n, summation sigma sine x equal to 1 to n fx or x square. This is what is the actual formula where fx is a discrete function. Okay, we have demonstrated it many times. I'll do it again. Okay, if I try to do it again, okay, we'll try to do it again. Now this is x-axis. This is x-axis, and I have a discrete for this is fx. This is fx, that is x square. So this is fx. Typically, this is fx. Okay, this is fx. Fx means x equal to 1, 2, 3, 4, 5, 6. At x equal to 1, it is 1 square. At x equal to 2, if I draw a line like this, it will hit fx. At x equal to 2, height will be x square again, 2 square, 3 square, 4 square, 5 square, 5 square, like so it will go. What is addition of all this height? First height is 1 square, 2 square, 3 square, 4 square, 5 square. What is equation of this line? That is fx, function over x, and it is x square, and it is not continuous though. It is discrete only. What is discrete means if I take x axis and x equal to 1, then it will go x equal to 1, height will be 1, x equal to height will be 4, x equal to 3 height will be 9, x equal to 4 height will be 4 square, x equal to 5 height will be 5 square, x equal to 6 height will be 6 square. Now in that fashion, if I connect all the top point of the vertical, then it will draw a line, and that line is this line. Though it is a that is a hold line. Someone will say that looks like a hold line. Hold line, HOLED, hold. There is a hole. Hold hold line. It is, yeah, certainly. It looks like a hold line. Okay, this we are trying to add all the verticals. Summation x equal to 1 to n function over x, that is x square. So x square will get summed up at x equal to 1, 2, 3, 4, 5, 6, 7, 8, like so, up to n square. What is the summation? Okay, now for the demonstration purpose, now someone will say it works for x starting from x equal to 0 also. We can take x equal to 0. X equal to 0, then it is 0 square. It is 0 square. Okay. Anyway, now if that is the case, if that is the case, okay, hop. If that is the case, now let's try another thing. What is another thing? Another thing is we have vertical at x equal to 1 as 1, x equal to 2 as 2, x equal to 3 as 3. Look, this is a blue pen. Okay, x equal, okay, black beard will I believe no one can see. So x equal to 1, x equal to 2, x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. Okay, I'll try if this is visible. Better. Okay. If x equal to 1, then height is 1, x equal to 2, height is 4, x equal to 3, height is 9, x equal to 4, height is 16, x equal to 5, height is 25. Like that it is going. If I connect all the points, then we are getting a line, and that equation is fx equal to x square. That is true. Okay, now let's take x equal to 1. Let's take three verticals. X equal to 1, x equal to 2, these are x, and height is function over x. At x equal to 1, at x equal to 1, x equal to 2, x equal to 3. What is this summation? Okay, let's take area now, because integration works in area. Integration does not work in verticals. It works in summation, works in vertical, and summation works only in vertical. Okay, if someone is saying, okay, I have summation of area, but that will behave as a vertical one. But integration works only in area. There is no vertical concept in integration. Can you sum all these verticals through integral calculus? Not possible. The technology is not there. Integral calculus technology itself is different. Okay, it works in different kind of scenario at all. Okay, in that manner, we need to have area to use the integral calculus. If I want to use integral calculus as technology, then I have to go with the area concept. And in the area concept, I have two areas. X equal to 1 to 2, I have one region. Between x equal to 1 and 2, I have one region. X equal to 2 to 3, I have another reason. There are two reasons I can see between x equal to 1, 2 and 3. There are three verticals now, 9, 4 and 1. Three verticals are there, and in between gap is there, and it forms exactly area section. Okay, can I divide three vertical into three areas? Three areas. Then another area will go from 3 to 4. Then we have three areas. Means I am trying to say, if I have one area between 1 and 2, that area corresponds to the first vertical. If I have area between 2 and 3, then it corresponds to area of second vertical, that is 4. If I have area between 3 and 4, then it corresponds to a vertical that is at 3, 9. For 9, I have area between 3 and 4. For 4, I have area between 2 and 3. For 1, I have area between 1 and 2. Okay, this much is understood. What do you want? I want another continuous function, a continuous, not discrete function. Consider this is a continuous function. This is a continuous function. If this is a continuous function, then if I say area between x equal to 1 and 2, then this area will go like this and it will hit this continuous function. What is the equation of this function? Consider gx. Consider equation of this function is gx. If equation of this function is gx, then it will come like this, and area between x equal to 1 and 2. This will make an area, and it will under the gx between x equal to 1 and 2, and this area will be exactly same as what we have vertical at x equal to 1. Means at x equal to 1, whatever value we had, that value will correspond to this area. What do you mean? This area is 1? Yeah, this area is 1. You are right. Someone is right. This area is meant. You mean that the area between x equal to 2 and 3 sub area that is going to hit gx between x equal to and 2 and 3 is same as the we had fx at x equal to 2. Yeah. What is fx at x equal to 2? That is 2 square, that is 4. Yeah. So this area will be 4. Last we had vertical of 9, 3 square. This 9 will be equal to this sub area that going to hit gx, and this sub area will be 9. You mean all three sub area under the gx will be exactly same as the fx vertical at 3 point. Yeah. Means sub area will go x equal to 1 to 3 plus 1. whereas summation is going x equal to 1 to 3. Makes sense? Summation is summation x equal to 1 to 3 fx equal to integration 1 to 2 gx dx plus 2 to 3 gx dx plus 3 to 4 gx dx. What do you mean? What I mean is 1 square plus 2 square plus 3 square equal to limit 1 to 2 gx dx plus 2 to 3 gx dx plus 3 to 4 gx dx. 3 to 4 gx dx will correspond to 3 square. 2 to 3 gx dx will correspond to 2 square. 1 to 2 gx dx will correspond to 1 square. Okay, if this is the concept, then what are you trying to show? Okay, if that is the concept, then we'll take any point x on x-axis x here. If I have at any x here, then what is the vertical? That is x square. That x square will match gx dx between x to x plus 1. Makes sense? Yeah, that will do. Then over, story is over. X to x plus 1, then the story is over. Means fx equal to limit x to x plus 1 gx dx. Now with this concept, I have to find gx. If gx is possible, then we can, at the end we will do the summation of gx dx from 1 to n plus 1, one more, because last subsection will be n to n plus 1. We find the solution. Please watch our previous video, and we have done it, and it came as n into n plus 1 into 2n plus 1 by 6. Okay, that is the repeated summation. Then what we are going to talk now? We will now, this is called how we prove our integral calculus. To prove integral calculus, then someone would say, anyone would jump now. What you did, man? You did x equal to 1 to 2, you took one subsection. Then 2 to 3, you took one subsection. Whereas I have three verticals only at 1, 2, and 3. You took extra subsection 3 to 4, because we are trying to match a subsection area of gx with the fx at the previous point. Can you take left side? Left side means if it is x1, x2, x3, then first subsection will be between x1 and x0. X equal to 0 and x1, you take one sub area. Then x1 and x2, you take one area. Then 2 to 3, you take one area. These three area. Now this first sub area will belong to right hand side x. This sub area will belong to right hand side x. This sub area will belong to right hand side x. What do you mean? I mean 1 square plus 2 square plus 3 square equal to limit 0 to 1 gx dx plus 1 to 2 gx dx plus 2 to 3 gx dx. Earlier it was 1 to 1, 2 to 3, 1 to 2, 2 to 3, 3 to 4 equal to 1 square plus 2 square plus 3 square. Now I am taking left side sub area. 1 square plus 2 square plus 3 square equal to limit 0 to 1. Left side area we are taking in gx. 0 to 1 gx dx. But this gx dx will be different than what we took right hand side. But at the end, when we finish the integration in term of n, then n should come same, because at the end summation is same only. Anyway, 0 to 1 gx dx or g2x dx, 1 to 2 g2x dx and 2 to 3 g2x dx. It is same as 0 to n g2x dx, whereas earlier was 1 to n plus 1 gx dx. Now we have 0 to n g2x dx. This g2x dx will be different. What do you mean? What I mean is, if I take any x, then at x, fx is x square. This fx is x square will be same as if I take left hand side sub area between x minus 1 to x. If I take one sub area that is going to hit gx, then that same area will be exactly same as this fx. Okay, what do you mean? Fx equal to limit x minus 1 to x gx dx. If you find gx in this manner, and it is possible, then we have found the gx. Then we will try the final sum from n to, sorry, 0 to n gx dx. So can someone try? Okay, If someone is trying, and this is very good because after that, if someone is getting, then he can compute the summation between any number to any number. What is summation between 8 square to 21 square? Then he will set limit to 8 to 21. Sorry, 8 minus 1 to 21. You would set limit 8 minus 1 to 21. Now it is 1 to 3, then 1 minus 1 to 3. If it is 1 to n, then 1 minus 1, 0 to n, he has to try. If he is taking area right side, then he has to try 1 to n plus 1. Now we are taking left side and we will start now. Okay, we have fx equal to x minus 1 to x gx dx. Fx equal to x minus 1 limit to x gx dx means fx equal to gx dx, dx equal to dfx by dx. Fx is x square 2x, we'll start with the 2x, dx equal to 2x, 2x integration is x square by 2, x square 1, limit x minus 1 to x, x square minus x square plus 2x minus 1, x square will go away, 2x minus 1 will remain, 2x minus where we want fx at x square and we are getting 2x minus 1. We are getting, if I just settle down the x1, then here it is x square, here it is 2x, means I have to multiply by x by 2 to have the same result. So we'll try now. We started with 2x, now I have to multiply by x by 2. So we'll start with x square now. X square dx is x to the power 3 by 3. X minus 1 to x, that will come as x to the power 3 minus x minus 1 to the power 3 whole by 3. That will be x to the power 3 minus x to the power 3, that will go away. Okay, next will be outside minus is there. Next will be 3x square minus 3x square minus 3x square plus 3x minus 1. If I settle down minus, it will become 3x square minus 3 up. It will come as 3x square minus 3x plus 1 divided by 3. X square minus x plus 1 by 3. X square is matching. This is what we want. Minus x is extra that we are saying. See, leave the 1 right now. Settle 1 by 1, order by order. Now, minus x extra we are getting. If minus x extra we are getting, we have to add x out there to settle it down. Means x square plus x, we will try again. X to the power 3 by 3 plus x square by 2. X to the power 3 by 3 would resolve into x square minus x plus 1 by 3. This is we have already seen. X square minus x plus 1 by 3. X square is the wanted one. So extra is minus x plus 1 by 3. Let's settle down plus x square by 2. 1 by 2 I can keep outside in bracket. It will be x square minus x minus 1 whole square. X square will go away. Okay, 2x minus 1 will remain. 2x minus 1. 2x minus 1. Outside 1 by 2 is waiting. X minus 1 by 2. X and minus x will go away. And this side we have 1 by 3 and this side we have minus 1 by 2. I think so. Yeah, minus 1 by 2. 1 by 3 minus 1 by 2 means it will come as minus 1 by 6. I have to add 1 by 6 again. Means now gx is x square plus x plus 1 by 6. We'll do integration. X to the power 3 by 3 plus x square by 2 plus 1 by 6 x. Limit is x minus 1 to x and full should become x square, that is fx. Okay, x to the power 3, x square will become x to the power 3 by 3. That will be settled down as x square minus x plus 1 by 3. X square is required one, so we will leave it. Minus x plus 1 by 3. X square by 2, 1 by 2 outside, inside it will become x square by 2. It will become 2x minus 1 by 2. 2x minus 1. Outside 1 by 2 is there x minus 1 by 2. First is minus x plus 1 by 3, x minus 1 by 2. Net will be 1 by 3 minus 1 by 2. That will be minus 1 by 6. I think so, 1 by 6. Now we have last term as 1 by 6. Integration is 1 by 6. 1 by 6 x. Now instead of x, I have to set the limit x minus 1 to x. X minus 1 plus 1. It will come plus 1 by 6. So 1 by 3 plus 1 by 6 minus 1 by 2, 0. Only x square will remain what we want. Means this has solved our problem. So our problem is solved in a manner that if gx equal to x square plus x plus 1 by 6, it solved the problem. What will be the final summation? Now if I have found gx, then I have to find the actual summation through area. Now I can calculate the area of the gx. If this is the gx, then I have to start from earlier the summation is from x equal to 1. So we will go 1 back, 0 to n. This sub area will give the actual calculation. 0 to 1 plus 1 to 2 plus 2 to 3 plus integration 0 to 1 gx dx plus 1 to 2 gx dx plus n minus 1 to n dx dx will be exactly same as summation x equal to 1 to n fx. Fx is x square. Now we will, if I add all the integration 0 to 1, 1 to 2, 2 to 3, n minus 1 to n, then it will come as integration 0 to n gx dx. We'll try now. It is x square plus x plus 6, x to the power 3 by 3 plus x square by 2 plus 1 by 6x. 0 to n, 0 will go away, n will remain. So net result is n to the power 3 by 3, n to the power 3 by 3 plus n square by 2 plus n. I can take out, okay, plus 1 by 6n. If I take denominator as 6, then it will become 2n square plus 3, 2n to the power 3 plus 3n square plus 6 plus n. That's it, by 6. Now n I can take outside, that it becomes 2n square plus 3n plus 1. 3n plus 1 I can make it 2n plus n. In that manner it will become 2n square plus 2n plus n plus 1. First two term I can take 2n as common factor. So 2n and then n plus 1. N plus 1 is as n also. More or less it will become n into 2n plus 1 into n plus 1 by 6. This is exactly same what we watched previous video. This is exactly same we had when we had taken right hand side. Dx dx from 1 to n plus 1. Here we are taking gx dx from minus 1, 0 to n. Earlier we had taken 1 to n plus 1. Gx will be different. I believe there gx was x square minus x plus 1 by 6. But here gx is x square plus x plus 1 by 6. That is different. Because limit is different, but result will come. This is something like verifying our own result. This is the way we verify our own result. Okay, we will take another summation, but this is mind-blowing, amazing, thrilling. If someone is stuck at some places that we have already discussed, then you can someone can expand it through Maclaurin series. There is no hindrance there. So then again, but answer will come in approximation. And anyway, the real answer people can find in the book. For those also, answer will come in approximation. Like, what is the square root of 1 plus a square root of 2 plus a square root of 3 plus a square root of 4? Like that. What is the solution? Okay. Their answer will come in approximation. It will not be very accurate result. Or 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. Answer will come in approximation. Or 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5. Answer. If numerator is high than denominator, then answer will come in approximation. Anyway, people can try. This solution is not available in any of the book. Calculating series summation through integral calculus. More or less, it is actually converting the discrete function into continuous function. That is the main fundamental behind it. And there is no work that has been done very substantially. how to convert a discrete function into a continuous function. Okay, some work has been done, some work has been Sir Taylor, he has talked about a continuous function can be can be can be broken into many continuous functions. This is what Sir Taylor has said. A continuous function can be broken into many continuous functions of polynomials, of set of polynomials. Whereas Sir Fourier is saying that addition of Sir Taylor is saying addition of polynomials can generate a function. If I have a function called any function, if I have log of x, a log of 1 plus x, that can be rewritten as summation of polynomials. Okay, then Sir Fourier is saying any function can be rewritten as summation of sinusoidal. Summation of sinusoidal, where each sinusoidal will have different frequency, different amplitude, and different phases. Whereas Sir Taylor is saying each polynomial will have different coefficients. That's if each polynomial has different coefficients, still we can regenerate the function by adding all the different order polynomials. Whereas Sir Fourier is saying we can regenerate any function through summation of many sinusoidal, where each sinusoidal has different frequency, different phase. Phase means if one is sin x, then another is sin x plus 45, sin x plus pi by 4. It has little bit different in phase. Okay, or different frequency. One is sine x, another is sine 2x. Frequency is double now. Okay, in that manner, they will be different. Or their amplitude. One is sine x, another is 2 sine x. Means 2 sine x means at x equal to pi by 2, sine x goes maximum 1. Whereas 2 sine x will go 2 as maximum. Amplitude is changing, frequency is changing, and phase shift is there. If I add all this sinusoidal, it will generate any function, repetitive function or periodic function or non-repetitive function. Anyway, we are talking that if there is a discrete function, then discrete function can be represented through a continuous function. Only difference is here to get anything, I have to have area calculation. But here I have to have get anything, I just need to add verticals. That is the difference. People use it heavily in probability and statistics if you have continuous function. And this is the way someone can proceed in this research to have continuous function. These are not available in any of them. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.